Hi, my name is PV Suryanarayana. In the IoT internship by Emertxe, the project I have built is home automation system using Arduino and Lab. Coming to the overview of the internship, during the internship I have learned is introduction to C, which consists of if else statements, data types, conditional statements, jump statements, loops, and etc. Introduction to C++. Next, sensors. In sensors I have learned LM35, which is a temperature system, and LDR, light dependent resistor, which is used for the sensing of the ambience light. And Arduino is a microcontroller, and I have learned the Arduino microcontroller and Arduino ID, which is an in the integrated development environment for the Arduino. And Blink is an web application, which is on a cloud based web application. It is also in a mobile app. And Pixim Lab is used for the simulation of the embedded systems, which is Arduino and other things. Virtual serial port in we can connect the virtual ports, um, etc. The goal of the internship: during my IoT internship at Emertxe, I mainly focused on the strengthening my programming skills like C and C++, learned microcontroller interfacing using Arduino, and simulate embedded systems with Lab. And I have also gained the hands-on experience in sensor integration, automation logic, and debugging techniques, and gained strong foundation for the IoT in application, real world applications, and future developments. Brief project requirements. The home automation system includes functional elements like heater, cooler, inlet, outlet, temperature, volume, and serial tank. Here heater, cooler are in temperature system, inlet, outlet are in serial tank. Temperature and volume are temperature is from temperature system, volume is from serial tank. User interface, we are using the Blink mobile application. We can also use the web application for PCs. And controlling elements are heater, cooler, inlet, and outlet. Heater, cooler controls the temperature. Inlet and outlet controls the flow of the water in the tank. And components are LM35 temperature system, Ethernet module for internet, LCD liquid crystal display with I2C communication, LED light emitting diode, LDR light dependent resistor. Coming to the block diagram, the main block is the Arduino, which is a microcontroller which controls the all peripherals with code. So the sensors are LDR, light dependent resistor, and temperature system, serial tank, LED, CLCD, and blink application. So LDR, light dependent resistor, changes the resistance based on the light intensity. With the help of the LDR, we can control the LED based on the daylight and evening light. It can be turned on and off based on the light intensity. And temperature system, here we can measure the temperature, uh, uh, surrounding temperature, and we can also increase the temperature or decrease the temperature by using the heat system and cool system, so which can be controlled by the blink app. And serial tank, in the serial tank the water level can be adjusted by using inlet and outlet. So the inlet and outlet are also controlled by the blink app. So in the temperature sensor we can also see the temperature in a gauge format, and we can see the volume also in the gauge format in the blink application. And we can display the sensors data like temperature in the CLCD display also for normal users. And for the online, we can see the data in the blink application. Brief about IoT. IoT is nothing but Internet of Things, which is connects the physical devices like sensors, microcontrollers, and applications to the internet, enabling them to collect the collect and exchange data in real time. It helps automation process, improves efficiency, and enables smart decision making across industries like healthcare, agriculture, manufacturing, and home automation. Project demo. Project demo setup, and the top the initialization is started and the tank is getting filled. So as we can see in the CLCD display, it is showing the 27.34 degrees as temperature, and the 660 as increasing is the water flow volume. And here side in we have inlet flow on. So here is the serial tank monitor, serial tank. So it is getting filled. It will get filled up to the threshold level, which is 2000 liters, sorry, 3000 liters, or 2990. So here outlet valve is button is pushed on, so the water flow will be going down. So up to certain level it will go down. After that it will automatically, the valve will automatically get on. Now heater. So the temperature will, here HTR on, heater is on. The temperature will increase slowly. So we can see 27.83 it increased, and a heater switch is off. Next cooler, is on, cooler switch is on. Next the fan is rotating, so it is getting some lag. Now switch is off, so cooler switch is off, fan stopped rotating. So now inlet valve again, as we can see, it is getting poured. So outlet valve, it is getting project code. This is the project code of home automation system using Blink controlled. So this is the ID of the Blink template, and this is the name of the Blink, and this is the authentication token. So here are the libraries: SPI, serial peripheral interface, Ethernet header file, and a simple Ethernet for Ethernet connection, var.h, and liquid crystal display I2C. And here are the header files: main.h, temperature system.h, ldr.h, next serial tank.h. So the authentication token is taken, and these are the switches for the inlet, outlet, cooler, heater. And next, this is the timer, and this is the LCD's starting line display. Next, this is the heater, cooler spin elements, and here is the heater pins, and this is the inlet valve, and this is the outlet valve. Next, the updated temperature will be displayed on the Blink application, and the water volume will also be displayed in the Blink application. This handles the temperature based on the threshold. Like if it reaches the 35 degrees, then it will automatically on the heater or cooler. Next, handles the tank. If it reaches the threshold like 2000 liters, it will automatically, inlet will be off. Next, the initialization part, LDR will be initialized and temperature system also initialized. Authentication token will be taken to initialize the Blink, and LCD in it, and backlight of the LCD, and LCD screen will be cleared. Next, LCD home cursor will be set to 00, and initially it will show the home automation. After 1 second, which is 1000 milliseconds, LCD will be cleared, and the serial tank initialization will be done, and the time interval be set, time interval for 1 second. For every 1 second, the reading, temperature reading will be taken, and here are the temperature and volume variables, and Blink run timer. reads the temperature, handles the temperature, handles the tank, volume display. Next cursor set the volume will be printed, which is the value, and temperature will be also be printed. This variable, these functions are defined in like LDR. This is the functions headings. Next, here the functions are defined. So initialization means pin mode will be set to green light, sorry, garden light, and the brightness control function is here. Light intensity, analog read, LDR sensor. Next, this thing will be coming from 0 to 1023 values, but for Arduino we take from 250, not Arduino, in Blink application for temperature reading gauge we take 225 to 0, sorry, not temperature, lighting, 225 to 0. So next, analog write, duty cycle, delay of 100 milliseconds. Next, LDR definition. This is the main, in which the temperature gauge, cooling pin, all the virtual pin will be set here, and the on and off condition, like on is 1, off is 0. Next, serial tank definitions are set here. And next, the functions will be defined here, serial tank. So these are the functions: inlet, outlet, enabling, enable inlet, enable outlet. Next, coming to the temperature headings, heater, cooler. Heater pin is 4 and cooler pin is 5, and this is the temperature sensor pin. Similarly, different serial tank. So here also LDR sensor is A1, and a garden light, which is an LED, is 3, and serial tank also. Okay. So temperature sensor definitions are here. Uh, Initializing the temperature is taking the pin mode, heater and cooler as an output, and reading temperature sensor. So temperature value is taken from the A0 pin, and which will be converted by using this formula. After they converted, it will return the temperature. The function will return the temperature. Next, cooler control. Cooler control will be like a binary, on or off. So digitally cooler on, cooler off. Similarly, same function for heater also, on, off. Okay, this is the coding part. Thank you.